Big data begets innovation, and our next power pitch will explain how one company's been able to break through speed, scale, and size barriers to accelerate research from big data in a big way. Please welcome Ami Gal from SQream.
Hi, everyone. Thank you for staying to listen to me. And thank you, Landmark, for the opportunity. I want to share with you today a few use cases that are pretty cool for the better of humankind. So SQream is about very large data sets, and we're going to see a few examples in a second. So what we do in a nutshell, we miniaturize the data center. We can scale to do very large data sets. And when we look at our competition, what we saw is a huge rack, floor-to-ceiling rack of Oracle. And we wanted to do the same job faster on a single machine. This was the reason we went and created the company. So what we do is we're using graphical processing units. Every GPU have thousands of computing cores. So it's a supercomputer in a very small chip. And on the small machine that you saw earlier, we can put 4 of them. So that's very good for fintech. We have quite a few fintech customers. That's very good for telcos. What I really wanted to do today is to show you some really challenging situation that we are working on these days with partners. One of the biggest medical centers in Israel is Heba, and it also has a genome research institute inside it. And one of the main things they do there, they research genome sequences in order to have better cancer treatments to patients. Every sequence is around 200 gigabytes of data. And it takes them 2 months to compare anomalies between 8 to 12 sequences. That's a lot of data. It's trillions of records that need to be analyzed precisely and very fast. So with SQream, they could compare hundreds and thousands of sequences in a few minutes. What that means, it means that more people will get the right cure and the precise cure for cancer in a faster manner. That means that more people will recover from cancer in this decade. This is one project, and we're doing a few of those. Another cool project we're doing with, on the cybersecurity is getting data from drones. So drones are keeping borders, and they're keeping lives of each one of us in city centers, trying to locate risks on very large data sets. And one of the limitations of this situation is you don't have much power in the field. You don't have more than a caravan. Usually, you have a car that you can actually work on, but you do have very high ingestion of data, and you have to be precise, and you have to be very fast. So we come up with a solution to put a big database in a box that is being used in different sites to keep borders from risks at real time. And it's very important. We are talking about trillions of records that have to be analyzed precisely. So one of the coolest ecosystem we are working with a few partners is the autonomous cars. There are hundreds of thousands of data points in cars, ingesting data in every second. Some of it is visual analytics, but a lot of it is actually data analytics. And a good part of it needs to be analyzed inside the car and to predict malfunctions, hazards, and so on. It's millions of little data bits you have to measure every second. So how do you do that? You can't put a rack inside a car. You have to put something that is miniaturized. And this is one of the things we can do with SQream. We can put a big database in a supercomputer in this size. This thing can analyze in real time 15 terabytes of data. It's a huge data set. So what we're doing with that, for example, is creating a black box for cars, just like you have in airplanes. And the only way to do that is if you have something like a supercomputer inside a car, or a supercomputer near the doctor when he examines certain patients. So this is what is SQream about. I remember 3 years ago when I was, or 4 years ago when I was looking for seed money, I came with these slides, and there were only a few believers. Today, we actually do this project worldwide. Thank you very much.